So we're going to have a look at resolving vectors. This all revolves around right angled triangles. So this is maths you already know, and basically is just trigonometry and Pythagoras. So we'll start here with I've got a vector velocity, so something is travelling along this line with a magnitude that's proportional to the length of this line. I can have a look, if I think this is diagonal and I've got the ground here, I can have a look at how much horizontal velocity this is carrying, how fast it's travelling relative to the ground by resolving this vector into the horizontal. If I have a look at this right angled triangle that I've got, V, the vector, is the hypotenuse, and the ground here, or the proportion of the vector that's going along the ground, is the adjacent side to the angle. So the thing that links these two together, the trigonometric identity that links these things together, will be cos theta equals adjacent over the hypotenuse. So what I can say, if I multiply h up here, I can say that the adjacent equals h cos theta. And a way that I can write that for this particular vector is that I can say that Vx, so the proportion of this vector that is going along the x-axis here, is equal to V cos theta, like that. Okay. I also want to have a look how much of this is going up in the vertical direction. So I want to see how quickly it's gaining height away from the ground. Now, it looks a bit funny to do it round this way, but what you need to be able to see is that these two triangles are equivalent, and that this side, this rectangle, is equal to this one. So in the same way that this is adjacent to the angle, this one's opposite it, and we still have the hypotenuse. And the trigonometric identity that links those together is that sine of the angle is equal to the opposite of the hypotenuse. Therefore, h sine theta equals the opposite, and I can write that as Vy equals V sine theta. So this one gives us a horizontal velocity, and this one gives us how quickly it's gaining in height. A really handy way to remember these, if I want to resolve the vector this way, I'm going through the angle. So we can say cos, you go through the angle. And if I want to resolve the vector this way, I'm going away from the angle, and we can say that it is a sin to go through the angle, because we don't want to go through the angle if it's sine. So those are how I remember how to resolve these vectors. Just a nice easy little couple of sentences. The other thing that we can do, I'm going to link it back just one more time. If I know what the horizontal velocity is, and I also know, or I can work out what the vertical velocity is, I can find the original vector. So the vector is always the hypotenuse. The overall vector is always the hypotenuse. And that's because times in multiplying by a trigonometric identity always either makes it the same length or shorter. So you can always bear that one in mind. That means that the right angle is always there, opposite the hypotenuse. So if I know the length of this and the length of this, if I was to say this is Vx and this is Vy, I can say that V, at least in magnitude, is equal to the square root of Vx squared plus Vy squared. So that's just from Pythagoras. This coming from the fact that the hypotenuse V squared, if I was to call that V, is equal to Vx squared plus Vy squared. If I know these two as well, I can also find out the angle there, which is also the angle to the ground. Those of you that have done GCSE maths, which is all of you, will hopefully recognise this as a Z angle, so that is the angle that it makes to the horizontal. These two things, theta and theta, they are equivalent. And I can find those by another trigonometric identity, because I've got the adjacent angle, the adjacent side there, sorry, and the opposite side there. The thing that links those two together would be tan theta is going to be equal to the opposite, Vy, over the adjacent, Vx. That's from SOHCAHTOA. So I can say then, with the inverse tan, that theta, the angle that it makes, is inverse tan of Vy over Vx. And in doing that, in doing those steps, we can work out the magnitude and the angle, the direction from the horizontal for a overall vector from a horizontal or from a resolved horizontal and vertical vector. So that is resolving vectors for AS Physics.